Okay, you've used your model kits to build these formulas. You learned the molecular formulas in Science 10. You learned the dot diagrams yesterday, and the structural diagrams aren't that far off from the dot and cross diagrams. Do you have your valence electrons around every chlorine? Notice we still call them chlorine, not chloride, right? Because that's a common mistake. Okay, so now I want to talk about the shape of these molecules. Okay, because what are these little dots and crosses representing? Electrons. And what charge do electrons have? Negative. And so they will repel from each other. Okay? So when they repel from each other, certain electrons have more repulsion power, like as if they were stronger magnets, than other electrons. And lone pairs have more repulsion power than the bonding electrons do. So when you built your water, does it look like this? No? No? Does it look flat like that? No. Hold it up. Hold your molecule up. In fact, it looks V-shaped. Oh, that's what we're going to call it. This is V-shaped. And so actually, if I ask you to draw it in the VSEPR theory, you want to draw it either V-shaped or upside down V. I don't really mind which direction. I did that on purpose, so it doesn't look like a V. Okay, it doesn't matter which way you draw it, but I want a V to form no matter how you tilt your head. Does that make sense? So that's the VSEPR shape. Why? Because here and here I have two pairs of lone pairs, right? 1, 2. Lone pair, 1, 2, another lone pair. And these huge, because remember, electrons aren't little dots, they're actually clouds. Remember that from your theory development so two huge, dense clouds that are pushing and repelling these bonding electrons in there. And so they push them downwards. Does that make sense? Say that again. Imagine two great big balloons, one balloon here, one balloon there. A small balloon, the two balloons push down these balloons here. Okay, or imagine they're magnets, all north poles. These are very strong.
Junior class
They're going to repel these weaker further than these guys repel away from each other. Everybody get it? And so this has a specific angle. Can't remember, I think it's 107. It's in your notes. I'm not really bothered about the angle, but the reason that they're in your notes is simply just to show you that they have an angle that's different from the next angle. So here we have your methane. Okay? Now I like to call this a camera. Oh, my sticks are all different lengths. Just a second, let me change them. A camera with a tripod on top. Okay, so imagine this is a camera, okay, and then you've got a tripod down below. Do you see that? Okay, so I can rotate it, it looks the same. I can rotate it, it looks the same. This is a symmetrical molecule. Okay, so it's symmetrical because no matter which way I rotate it, it's the same thing the whole way around. Everybody okay with that? That's going to come in handy later on. And we call this tetrahedral. Okay, so its shape is tetrahedral. Now here's a problem. This is a flat board. You're writing on a flat piece of paper. This is not a flat molecule. So if I want to design the shape for you, I have to show you that this is a tripod down below and that this is a sticky up bit. So this is how I show you. Are you ready? So here's my carbon. Everybody okay? Black carbon, black carbon. Here's my hydrogen sticking straight up. That's this one right there. Okay? Here's this hydrogen going this way. Everybody okay with that? If I were to smack that into the board, this would just be level with the board and that would be level with the board. Everybody okay with that? But this guy, he's coming out of the board. This one right here. You see that? It's coming out of the board towards you. So I'm going to draw it like you would like perspective drawing, a small thing going towards you like this. Okay, but actually, hold on, he's kind of almost pointing towards the door. So, like that. That's this one. Everybody get it? So he's coming towards you, and actually he's going towards the door as well. Are you okay with that? And then, remember, this is flat into the wall, or into the, wall. This one's going straight ahead, this one's going straight ahead, this one's coming towards you and towards the wall, but actually also towards the door, but into the board is this guy. And I'm going to draw him like this, with a dash. Like that. Like an echo, going away, 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 away. Okay? So the echo starts large, and goes small, and there's your fourth and final H. And this shows a tripod with a hydrogen on top. And each of these angles is exactly the same. Okay? Each of those angles is exactly the same, 109.5 or something like that. Because, and you can tell because no matter how I rotate it, it looks exactly the same, so they must be the same angle. Everybody get that? And it doesn't matter if these are hydrogens or chlorines. May I? Thank you. I hope you said yes. Because you still have the same shape. So it's not the outside that dictates it, but rather the fact that we have 4 bonding electrons that dictates the shape for us. Everybody okay with tetrahedral? Okay? Okay, good. So what's the next one? So this is as well going to be tetrahedral. So I would do the same thing again, and the reason I was getting to do this is just practice. So how would we draw this one? A C with a line up, Cl, a line over, Cl, a dash, and a wedge. Okay? Everybody understand what the dashes and wedges are trying to represent? Towards you, away from you. Okay. Let's look at your ammonia then. Borrow these. Okay. So ammonia only has 3 sticks as opposed to the 4 tetrahedral. So this, that sat up there, our camera, what's our camera? Is it another hydrogen like it was in tetrahedral? No. What's here? On the top of my nitrogen. What's on the top of my nitrogen? A lone pair. What did I tell you about the repulsion power of lone pairs? Stronger. Good, Molly. Stronger than the bonding electrons. Right? So you've got this huge lone pair sat here that's pushing the rest down into a tripod. Get it? Otherwise it'd be nice and flat. But it's not. So this, and the angles are different. Have a look at your, like put one tripod beside the other, and can you see that your tetrahedral is a different shaped tripod on the bottom than the, I don't have 3 that are the same, that's okay, than this guy. You see how this guy's flatter than this? Okay, so they are different angles. So this has to have a different name. But I still need to show that this is a tripod. How do I show a tripod again? Oh, just like that. So here's my nitrogen, here's my hydrogen, here's my dash. Oops, put a Cl there, sorry. We didn't build them with Cls, we built them with H's, and there's a wedge. Dash. This is a wedge, this is a dash. Okay. Everybody okay with that? So it's just the tripod. What makes it the tripod? The repulsion of the electrons at the top, the lone pair. Now this is called trigonal planar. No, it's not. No, it's not. It's called pyramidal. Because it looks like a, right. Happy? Okay, hold up your carbon dioxide. Okay? Does it look like the way we drew it? Oh yeah, look at that. Okay? So this looks like a line. So we're going to call it linear. That's nice and easy, like a linear line in math. Okay? So this is linear. And your VSEPR diagram would look the same as this structural diagram. Just nice, long, straight. No dashes, no wedges needed. Everything's on the plane of the paper. It's just a line. Okay? Make sense? Okay, so moving on to your ethene. Oh, well now, this is where I introduced to you the concept about the central atom. Okay, I'll just for a second here pause. What was this shape again? Tetrahedral. Why is it tetrahedral? Because of the position of these 4 sticks that you see right now. What happens if I replace this and change it from methanol, or from methane, into methanol, like this, like you made yesterday? Okay, so carbon, hydrogen, 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 oxygen, hydrogen. Everybody okay with that? Now I have 2 central atoms. I have this one. What shape is that? Stick, 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 stick.
Pyramidal.
No. What shape is that? Tetrahedral. Because it was before. Everybody okay? And so its central atom carbon is tetrahedral shaped. And methanol's other central atom oxygen is, what shape is this? V-shaped, if I kind of cover that up so you don't see it. So I have 2 shapes in this molecule. I have tetrahedral and I have V-shaped. Did you get that? V-shaped around the oxygen, tetrahedral around the carbon. Okay, so here I also have 2. I have this carbon and I have this carbon. Okay? This carbon, so just looking at one carbon, what shape is that?
V.
Oh, but except for I've got another stick coming down.
Tetrahedral.
In fact, you kind of almost look at it like a Y. Doesn't it look like a Y to you? A Y shape? It'd be great if they called it Y-shaped, but they didn't. Okay? What they called it was, the mistake I made earlier, trigonal planar. Because Y was just too easy. You already got V, so you need to have something more complicated, I guess. I don't know. So instead of Y shape, first of all, it goes like this. Carbon, that's how we draw it. Carbon, and we draw it like the Y, like that. So that's like this. Okay? So hydrogen, hydrogen, carbon, double bond. So it looks like a Y. Okay? And then I'm going to go to the other side. I'm going to draw the second Y on this side. Carbon, hydrogen, hydrogen. So that's how we draw it. I'm just going to draw a little neater here for you. Okay? That's how we draw it. Remember yesterday? That might have been in the other class, actually. I'll just skip that Y part. Okay, so Y-shaped. Y, 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 Y. Okay? And we call it, what did I say we call it? Trigonal planar. Because it's plane, as in like flat, like the prairies are plains. Okay, so it's flat like the plains. These are notes in your package, don't worry. So it's flat like the plains. And trigonal because there's 3. Tri. Okay, so the name does make sense, but Y would have been way better. Okay? And why does it look like a Y? And not pyramidal?
Because that's the stick coming back. There's a stick connecting the stick.
What made the pyramidal look like a pyramid? What pushes it down into that tripod? That lone pair, right? You've got a lone pair here that's pushing this tripod down. Do you have anything on here that's going to push these 3 points down? No, nothing. Okay? So therefore, it's going to be repelling as far away from each other as possible. Well, that's not this, because these guys are pretty close, actually. They're closer than they would be if they were flat. So therefore, these guys are flat because they have nothing else to push it down and force it to be a little bit closer. Okay, so VSEPR stands for, and this is all in your notes, valence shell, because isn't that what we're talking about here? I don't really care about all the other rings. We're talking about the valence shell. So it's valence shell, electron pair, whether they are bond pairs or lone pairs, repulsion, because they're repelling, theory. Valence shell, electron pair, repulsion, theory. Okay? Now lots of stuff that you read about, or if you have a tutor or in your snap book, they start making you memorize how many bonding electrons. If you have 2 bonding electrons and you have two bonding electrons and 2 lone pairs, it will be V-shaped. If you have 4 bonding electrons and 0 lone pairs, it'll be tetrahedral. Okay, now, and that's true, and it makes sense, but it sounds like a whole lot of memorization. So what I prefer my students to do is this. If you can nail these, and you understand them, and you can see them, then no matter what, let's take my water again. No matter what, this is H2O. Everybody okay with that? But if I asked you to draw I need a different color bore marker, please. Oh no. If I asked you to draw H2S, you know H2S gas? The stinky stuff? If I asked you to H2S gas, sulfur's in group 6, so it would have 6, just like that, 1, 2, 3, 4, 5, 6. And so what shape would it be? V-shaped, because when you build it, it's going to look like this. I'd much rather you sort of follow the pattern. If you know oxygen's this, and you know oxygen looks like this, then anything in group 6 will look like this. Because they'll all have 2 things to push it down. And even if it's not hydrogen there, but it is chlorine instead, what shape? V shape. Because you built it, it looks the same. So memorizing that is fine, but understanding it and seeing it is better. Okay? All right, so in your note package, you will see, I'll just call this back up onto the board. In your note package, you see this isn't even my chicken scratch, this is an old student's chicken scratch. So it talks about the tetrahedral, the pyramidal, the V-shaped, the trigonal planar, the definition of valence shell, the linear, the combination of methanol, which we just had the conversation about. So everything I just said is right here. Okay? Central atoms have 2 or more bonding electrons. Start by identifying your central atoms if they're complicated. 2 or more sticks coming off of it makes it a central atom. Okay, so to practice, here's this sheet. You're going to draw the Lewis diagram. That's the dot diagram. Then I want you to draw the shape. That means I need dashes and wedges if it has dashes and wedges. Okay, if it's supposed to look like a Y, it looks like a Y, etc. And then you name the shape on this column. But, oh yeah, I just remembered. It was easier for students to swap these columns because they wanted more space to draw it. So I don't really mind. If you want to name it here, right, if it's easy to write tetrahedral in here, but leave you a bit of more space to draw it, that's cool. Okay, so we're going to start by doing this and have a bit of practice.